Alright, welcome back, class. Today we're going to be learning about factor and remainder theorem. So we're going to be doing long division and synthetic division. Different from synthetic substitution, but it's almost the same process. Again, go ahead and try these 4 warm-ups again tomorrow in class. Like usual, I'm going to be calling on 4 volunteers. You're going to come up here and show us how to solve these. Okay? So let's just review briefly. The 4 methods we went over. The first one, we're talking about factoring, the one that works like 98% of the time, box method. Second one is GCF, greatest common factor. Third one, cubic formulas. And then the last one is factor by grouping. Okay. And factor by grouping usually works with 4 terms. But again, like you've seen in the video in 5.4, I emphasize to just use the box method. But you should know in the back of your head how to use grouping. All right. So like I said, we're going to go over remainder and factor theorems. Pretty much what that is we're going to be using long division for polynomials and using synthetic division as well. Okay. So again, hopefully by the end of this video, you'll be masters at long division and synthetic division. Okay. And again, I'm going to emphasize long division works sometimes, synthetic division works most of the time, like 99% of the time. Alright, so if this is kind of confusing, which I know it is, if you start reading it, polynomial long division can be used to divide a polynomial f of x by a divisor d of x, producing a quotient q of x and a remainder r of x. Just let me do an obvious division problem. So we have 10 divided by 3, okay? How many times does 3 go into 10? 3 times. 3 times 3 is 9. Remember, we always subtract. 10 minus 9 is 1. And again, I could keep going by adding a decimal, but this is enough just so that we know what a polynomial long division is. This right here is known as your f of x. Okay. Whatever you get here is known as your remainder, r of x. Okay. D of x is what you're dividing. And then this is your q of x. So hopefully that helps out with the definition. Synthetic division, okay, can be used to divide any polynomial by a divisor of the form x plus or minus k, where k is an integer. So pay attention very closely to the definition. Remember that the degree is 1. Okay? So synthetic division only works when the degree is 1. It does not work when the degree is 2. Okay? So therefore, I'm going to force you to use long division. Okay? Some theorems you should know. Remainder theorem. So if a polynomial f of x is divided by x minus k, then the remainder is r equal f of x. Factor theorem just says a polynomial f of x has a factor x minus k if and only if that k you plug in or the x you plug in is going to be a 0. And again, we're going to see a couple of examples in just a moment. Alright, let's go ahead and divide using polynomial long division. Okay. One thing to remember, I emphasized a lot on polynomials being in standard form. Okay, if you forgot, remember, standard form just means that the numbers have to go from biggest or from largest to smallest, or what you call descending order. So like 5, 4, 3, 2, 1, 0. Okay. That's important when you're talking about synthetic division and log division. Alright, let's begin. Alright, so right here, I'm dividing x to the power of 4 plus 1 by x plus 1. So x plus 1 is my d of x, that goes on the outside. And go ahead and create your little division bar. X to the 4th, okay, plus 1 is not in standard form. So you have to put it in standard form. So again, you ask yourself, what comes before 4? Okay, then it's 3, so you go ahead and add plus 0x cubed. Then go ahead and add the next one. What comes before 3 is 2, 0x cubed, x squared. What comes before 2 is 1, which is 0x. And then you're left with 1 at the end. Okay. So again, the most important thing is make sure that your f of x is in standard form. If not, you have to add in the zeros. Alright, here we go. So x goes into x to the 4th. So you're asking yourself, how many times can I get x to become x to the 4th? So that is x cubed. Okay. So go ahead and multiply. So x cubed times x is going to be x to the 4th. X cubed times 1 is just x cubed. And remember, since you have two terms, go ahead and put parentheses because you have to distribute the negative to both the terms. Okay. Alright, so your goal when you're doing long division, make sure that the first term, you always eliminate it. If you don't, you're doing something wrong. Okay. Go ahead, so get rid of this. 0 minus 1x cubed is negative x cubed. Alright, so now go ahead and bring down the next term. We have 0x squared and negative x cubed. So you ask yourself, how do you get x to become negative x cubed? Okay, so that is negative x squared. So negative x squared times x is negative x cubed, which is what you want. These two have to be exactly the same. Negative x cubed, x squared times 1 is negative x squared. But remember, every time you're moving on to the next line, you're always subtracting. Alright, so a negative times a negative is a positive, and when you add that to the negative x cubed, these are gone. Negative times a negative is a positive, 1 plus 0 is still 1, x squared. Alright, next, go ahead and bring down the 0x. And now we continue the process. Okay? So how do you get x to become x squared? That means you have to multiply by x. And now you have to distribute the x to both these terms. So negative x times x is negative, should be a positive. Positive x times x is x squared. Positive x times 1 is positive x. Don't forget the parentheses and the negative. Again, my goal is to get rid of the first one, which we do. A negative times an x is a negative x. Okay. We're almost there. Last, go ahead and bring down the 1. And now you ask yourself, how do you get x to become negative x? You have to multiply by negative 1. Again, multiply that negative 1 times x gives me negative x. Negative 1 times positive 1 is negative 1. I'm running out of room here. Negative times a negative is a positive, so this is gone. A negative times a negative is a positive, 1 plus 1 is 2. Okay. So now, how do you write your answer? Okay. So, you take this is your d of x, this is your f of x, this is your q of x. That's called your quotient. So you take your quotient, and go ahead and write it in the middle. Take your quotient, so x cubed minus x squared plus x minus 1 plus, this is going to be your remainder over your divisor. So my remainder was positive 2, which comes from here, and my divisor is x plus 1. And that's how you use long division. Okay. Again, let me review. This right here is called your quotient, which is your answer, plus your remainder over your divisor. Okay. So this right here is known as long division. Okay. I don't know, to me this is pretty painful. I think synthetic division is much easier, but again, you can't always use synthetic division. Sometimes you're forced to use long division. Okay. All right. Let me go ahead and do one more example for you. All right, so tomorrow in class, again, I'm going to call up on students to do number 2 and number 3. We're going to go ahead and do number 4 right now. Okay. Again, make sure, the most important thing when you're doing long division, make sure that your f of x, okay, which you're dividing, and your d of x, which is your divisor, is always in standard form. Okay. So let's go ahead and write this again. So we have x cubed plus 5. We're missing terms here. Divided by 2x squared minus 1. We're also missing terms there. Okay. All right. Let me go ahead and put my divisor on the outside. Again, what comes before 2 is 1, so I'm going to go ahead and add 0x, okay? Because again, it has to be in standard form. If not, then your answer is going to be completely different than mine. All right, let's look at your f of x, your function, which is, or your polynomial. This is x cubed, and you ask yourself, what comes before 3? 2. 2's not there, so you have to add that. What comes before 2 is 1. It's not there either. So I have to add 0x squared with 0x. And then 0 is there. So you have to go ahead and add positive 5. All right, so once you add those two terms, now we're ready to go ahead and divide. Okay. All right, so you ask yourself, how do you get 2x squared to become x cubed? Okay. So how do you get 2 to become 1? You have to multiply by a fraction. Okay. So you have to multiply by 1/2 x. Right? Half of 2 is 1. So multiply. 1/2 times 2 is 1. X times x squared is x cubed. 1/2 times 0 is still 0, x squared. And then 1/2 times negative 1 is negative 1/2 x. Okay. All right, so did I eliminate the first term? A negative x cubed plus an x cubed is gone, so I did good. 0 minus 0 is still 0x squared. And then negative times the negative is positive 1/2 x. Okay. All right, go ahead and read down the 5. And now you ask yourself, how do you get 2 to become 0? Okay. And you don't, right? So pretty much what happens here is you ask yourself, okay, can 2 become 0? If you multiply 0, let's go ahead and do it, we're still going to get 0 at the end. So when you get to this point, you're pretty much done, okay? What happens now is, now you could go ahead and write your answer. All right, so we have 1/2 x plus our remainder, which is x squared, plus, well, 0x squared. You don't have to write this 0x squared because it's gone. So I'm just going to write 1/2 x plus 5 over 2x squared minus 1. So hopefully that made sense. Okay? If it didn't, I'm going to go ahead and explain it. Okay? The reason we stop here is because 0 times anything is 0. Okay? Since this number right here is higher than this degree here, then that means you're done. Because you can't get a 2 to become a 1. Okay? So that's how you know you're finished. When this degree is lower, it's smaller than this degree on the bottom. Okay? So this is my answer. And again, this one was challenging just because I know you guys do not like fractions. I'm pretty sure you're going to get fractions on your homework. Okay. All right. So go ahead and do 2 and 3, and tomorrow in class I'm going to ask you to complete those. And again, I'm going to call up on some volunteers. Okay? Mr. Mira out.